Good morning, students. In today's class, we'll just discuss about what we studied in the previous classes, right? So we just start our today's class with the previous classes. We just started with solid state physics since we had a gap, right? Complete nearly 1 month gap. So we just start our today's class with the unit one, that is chapter one. And then in this particular class, we'll just have a very quick revision what we actually started the physics, solid state physics. Now, when we start with the solid state physics, you can just see that what is our aim. So our aim is to explain the properties of different solid materials which are found on the surface of the earth. And this particular materials which is found on the surface of the earth can easily be explained by means of some mathematical verifications. So whatever the fact that we are trying to understand, that fact should be verified mathematically for each and every statement what you just uh, tell you, right? So the given hypothesis should be verified mathematically. And this particular properties of these solid materials have been explained in terms of the solid Schrodinger equations, all right? But that we have already discussed. So now this the different behavior of the particles which are residing inside the solid materials. We just started our topic with the crystalline solids, right? So now in this particular chapter, we have given due importance to the materials which are existing on the surface of the earth. And when I say the particularly we are dealing with the solid material. So these solid materials, what are the content or what are the how the um, arrangement of these constituent particles which are residing inside the solid material? We'll just see in today's class, right? We just see in today's class the materials which are exhibiting the different properties of the what you can say variation of different properties that actually will be deal with, right? So here we just started our topic of chapter one with the different types of materials which are available on the surface of the earth, and these solid materials which are available on the surface of the earth has been classified broadly classified into two categories, that is crystalline solids and also the non-crystalline solids. When you can see this, so the crystalline solid, how you define this crystalline solid, and what is the what you can say the uh, importance of these crystalline solids, right? So here we just start our classification of solid. So the many important solids are crystalline. The solids which are available on the surface of the earth are differently categorized with the with the classification that is crystalline and non-crystalline. So here we just start our topic. We have started with the crystalline solid. So in order to understand more clearly the crystalline solid and the difference between the non-crystalline solids or the materials. So now here we just start our today's topic with the solid. We have started with this solid state physics. So solid state physics is also known as condensed matter physics, as it will give us the information regarding the various nature of the atoms or the molecules or the ion which are placed with respect to one another in very closely to each other. So now when we just started our important discussion, so here what is the need of studying this solid this materials character or the properties? So there is a direct relationship. You can see this. There is an entire computer and the electronics industries completely depends upon the different classes of materials. And here, the class of materials we are looking into our talk is the semiconductors. So you can just see this. The computer and electronic industries are completely depending upon the a different material that is called semiconductor, which is a solid, which is in the solid form. And here, and also we just deal with the we can just say that this semiconductor can also be known as metal and non-metal, metal and insulator bond. So what is this semiconductor? Semi means it is at one time it will act as a conductor at a particular temperature. One time means what? At a particular temperature, the same material is acting as a conductor, and the same material at a particular temperature will act as a insulator. Now that is a very special character of the solid material which we are trying to study, that is semiconductor. So this particular importance of the semiconductor is given the what you can say a prime point of study. So here we are interested in studying the semiconducting material, since it is a solid material, right? And which is having a very important, significant in the computer and electronic industries, right? So yeah, either you may be some CSC, computer science engineering computers. When I say computers, so this is not exactly what you can say applicable for only CSC student, but also the different branches which are there apart from the computer science engineering and the you can just say that is mechanical, triple E, VCE, right? Civil engineering, and so on. So we'll have a broad aspect of the semiconductor study. So that is the reason that, see, here in this particular talk, what we are trying to do is that why this particular solid state material or condensed matter, condensed solid material is of a geo importance, right? For computer and electronic industries particularly. So here we just this is due to this reason, right? So we are just starting our talk of solid state physics, which is uh, providing us a good background to understand what is happening to the semiconducting material and what is inside the semiconducting material, how the solid materials in which the constant particles are arranged, and we just discuss the different properties, right? So now when I say that when you talk about the engineering, right? So you need to understand. I'm talking about the technology, right? So different technology depends upon the new technology. Wherever they see day by day, technology is advancing. So definitely this technology is developing, and how it is developing, and it is particularly depending upon the different classes of the materials which are available on the surface of the earth. So now we just see that there is a what you can say a very simple understanding of this solid material which we are trying to understand the character. Now, this particular solid state physics that you are studying in this particular course is completely associated with the technology. When we say science, right? Science, the application of science is nothing but the technology. So, in order to understand this, how to use this technology, you need to understand the basic concepts of the science, right? So, that is what actually we are trying to do here. So, you already have the information right about the metals, insulator, and the superconductor, and they are nothing but they come under the category of the carbon, right? So now, what is actually we are trying to study now, at this particular level, I think that you had a very good information, right? What is what and what actually we are trying to uh, understand in the chapter one. So here, the basic concepts of the crystal, right? So I told you that the solid material which is found on the surface of the earth has been classified into crystalline solids and non-crystalline solid. So in the chapter one, we have already discussed that the elementary crystallography. What is this elementary crystallography? The crystallography is nothing but is a study of the what you can say the crystals. So by incidenting some X-ray or neutron beam and so on, so by incidentating that particular beam on the crystal, we can just study the location of the constituent particles, how they are resided inside the solid material, and depending upon their position, either it will be fixed position or they are varying. So that depending upon that position, one can just know that how these materials can be used for different application purpose for the, as I told you, for the computer science and also the electronic industry, right? So here we are just giving our more what you can say concentration to the materials, starting with the fundamentals of this crystallographic material. What is actually see, we cannot see the constituent particle. Either it may be atoms. You already are aware about this fact that we cannot directly see the atoms or molecules or the ions. So now the question arises that if you want to understand uh, the position or the character of the constituent particles. See, whenever I say constituent particles, that means that it is nothing but the atoms, molecules, or it may be the ions. So whenever we are trying to understand this fixed particles position or character, you need to assume that there may be some this particular material constituent particles are may be arranged in a particular format that I will show you. So this is here from now at this particular point, we need to understand, we need to just have a visualization that how these constituent particles may be located. And at last, we'll come to the conclusion that how these materials can be seen, that how they are fixed and how the character of these materials are varying when you apply the particular force to this material. So what is happening to the position of the constituent particles and so how this can be utilized for different practical applications, right? So here we just starting with today's talk about the crystallography fundamentals. So we need to understand, since we cannot see from the naked eye how the atoms or molecules or the ions are fixed inside the solid material. In the lower classes, we just had the information, right? So that these, when I talk about solid material, it means that the atoms or molecules are closely packed with each other. Okay, so since they are, we just say that it is closely packed. So when here in engineering level, we want to study how a neighboring atom with the other atom are exactly located inside the solid material. So to understand this particular aspect, you need to visualize. So that visualization will help you in understanding the position of these constituent particles, right? So here, from here, we just start our next important aspect of crystal lattice crystal structure and different types of lattices. Here, when I talk about lattice, right? So since we are starting about the assumption of the uh, given particle, so now we just say that we are dealing with the crystal lattice. Lattice is nothing but the imaginary points. Here, we just say that lattice is nothing but the imaginary point. So here, we'll discuss in today's class about the crystallography. Just now, I told you that the basic fundamentals of crystallography is nothing but the solid materials, which has been classified into three important branches, that is crystalline, polycrystalline, and the amorphous. So here we just started our topic of the crystallography. It is nothing but it is a study of the crystal. Inside that crystal, the constituent particles positioned by incidenting the electron beam or the neutron beam or the X-ray beam onto the crystal. And we need to visualize some important parameters if you understand, if you want to understand the position of the constituent particles, that is crystal lattice, crystal structure, and different types of the positions of this particular important imaginary points, that is for types of lattices. Then we'll discuss about the unit cell and also the directions, planes, and Miller indices in the cubic unit cell. And so and definitely we'll just study about different crystal structures and the symmetry. Symmetry is the elements of different symmetry, right? So symmetry is similar properties which are exhibited by different crystals, right? So we just say that is called symmetry. Symmetry is nothing but it is equal, and we can just say that with respect to the neighboring constituent particle with the other, so that will be in the similar fashion. The arrangement is in the similar fashion. And then the chapter 2, which deals with it, what I told you about the crystallography, when you are just incidenting X-ray or neutron beam or the electron beam on the crystal in order to study the character of that particular crystal. So here in this particular chapter 2, since we in chapter 1 we had very clear information regarding that how this arrangement of the constant particles are there. Now we know the exact structure of the crystal. That is, you can just see this. That is the reason that it has been mentioned here. That is the crystal structure. Here, X-ray crystallography means, so now a student from the chapter 1 will have an information, right? See the different positions of the particle, and depending upon this different physical position of the particles, and also the different symmetry elements which are exhibited by these constant particles, how this particular crystals have been classified into different crystal systems. So from chapter 1, a student should know the basic definitions of the crystal lattice, phase lattice, right, and the basis, and also he will understand how the structure of the crystal is formed, and what are the things which are there inside the structure of the crystal, and how, depending upon these crystal structure, different lattice parameters which will give us the information, right, how these crystal systems have been classified broadly into 7 categories. So depending upon the lattice parameter, different crystal systems, and what are the different examples which we see in our daily life, and also for the industrial purpose, different crystal examples, crystal systems examples. So that particular aspect should be very clear information we'll get from the chapter 1. Here, since we know that what is happening in chapter 1, then we just go for chapter 2, that is X-ray crystallography. In this X-ray crystallography, we just studied about the now we had a full, we know that different crystal system. Now what we are doing here is that we are just inserting this X-ray beam on uh, on the crystal. So what will happen when the X-ray beam is incident? So we just have a visual. We will visualize that whenever we are incidentating some X-ray on our body. So what will happen, right? Some of the rays, right? Most of the rays will travel inside the body, and we get information about the what you can say, the hard elements which are residing in our body. In the same fashion, whenever we are incidentating an X-ray, what is happening? It is getting diffracted. So that is the reason that he will just say that that is called diffraction, and these diffractions should be in accordance with the mathematical equation that is called Bragg's equation. To the sin theta is equal to n lambda. And what are different methods by which we can know the different properties of the crystals, right? So that are called X-ray diffraction methods. Here we are giving our importance to the. Here we just discuss about the powder method. Then X-ray diffraction method, you'll find that different methods are there. So we have given our due importance to the powder method. So what is how we can start study the different nature of the crystals, right? So either it may be the single crystal or polycrystal or the right. So here that we studied, right? Now in this particular chapter 1, we just studied about the uh, see, we need to understand unit cell. So when I say unit cell, it is three, what you can say, smallest possible a figure which can be drawn in 3 dimensions, right? So now, what is the use of studying unit cell, right? So we can just know how this crystal system, by depending upon this unit cell, they have been classified into different crystal systems, right? This information we have, right? The solid materials have been classified into different, what you can say, solids, liquids, what is solid and what is liquid and what is gases, right? The crystals, you can just say that we just had an important discussion about these crystals. So these are, we can just say that is they are fixed at different points, and we can just take that these particular solids can have different class branches, right? Crystalline, polycrystalline, and amorphous. So in the first part, we just discuss about solids, and in the second part, we just discuss about the crystals, polycrystals, and the amorphous. Now, what is happening at a particular temperature, pressure, and volume? Definitely, they are bonded. The constant particles are bonded with each other, right? So you require more energy to break this particular bond. So now we can just say that the examples we have seen in the first class itself, these are a few examples of the, when I say crystalline solid, so single crystal, this is the example. When I say a polycrystalline solid, you can just see you can just view this schematic image. We can just say this is called a polycrystalline solid. Very different crystals, polycrystalline and the amorphous. Each type is, you can just see this, they are at a fixed positions, right? Now, this is what semantic image that we found for the crystalline solid. So when you say crystalline solid, they are arranged, the atoms or molecules are arranged at a definite positions, and these particular points are repeated. Here you can just see these points are completely repeated, right? This point, see again, this is at a particular distance, the same distance it has been repeated. So we just say that crystalline solid is a form of substance in which the atoms are arranged in a definite and repeated pattern in 3 dimensions. So that actually we studied in the previous classes, the starting level. So you can just see this example of the crystal inside a single crystal, which is available on the surface of the earth, right? Not in the pure form. There's just a single pyrite crystal. So it will be there at the particular fixed with the different materials, and we want to extract that. So we are extracting that. So that is the example of single crystal. And the polycrystal, you can just say this polycrystalline solid. So this is pyrite form, grain form. You can just say this what is actually grain. Inside this polycrystalline, the crystal is there, another crystal is attached to it. So we just say that as different crystals have here. When I talk about polycrystalline, so polycrystalline is completely consisting of different single crystals, right, which are accommodated in a given shape. You can see this is the example which is given to you. That is for polycrystalline solid. And then we have gone for the amorphous solid, so which is completely, we say that that is called a non-crystalline solid, which is composed of the randomly oriented atoms and the ions, which do not form a definite pattern. So the what you can say the exact structure. You can just see this particular arrangement of each atom with respect to the another atom. They are not unevenly distributed in the space, right? This is what actually, and how this uneven distribution that is semantically view, and this is what we are trying to study, that is called the amorphous solid, or we just say this amorphous silicon, which can be used. And why we are studying, I just told you that is of your entire computer science engineering and the electronic industry deals with the semiconducting material, right? You had very good information regarding this. So the examples of the amorphous materials, so either it may be the silicon. So silicon, you know that the silicon and germanium are the important materials, solid materials, which are resembling a significant position in the, so what you can say, the electronic or computer science engineering. And definitely apart from that, when you say computers, we can just, by using this amorphous silicon, you can just use this in the solar cells and thin film transistors, right? So here we just discuss this particular topic. We just already discussed this different crystalline and non-crystalline and the amorphous solid. So why we have taken this again? Why I have taken this particular topic, which you already have in the information, right? So since I want to just explain you the importance of the solid materials, which actually we studied in the entire first unit, second unit, and the third unit, whatever we started, right? So I want to tell you that this particular three important classification of the solids, the entire syllabus of US engineering physics is being dependent upon these three classifications. So with this, I just information, right? So I just take a leave for today's class, and tomorrow's class we just start our the third unit, that is chapter 2, third unit 3. So in this today's class, I think that you got some information which we have already given to you, but still this is a revised revision class for what actually we try to study in this particular syllabus, right? So here we are very much interested in the studying about these different branches of the what you can solid materials. So okay, thank you everyone. We'll just meet on the next class. Thank you.